Hey everyone. So if you have ever managed a network, I'm sure you've run into this incredibly frustrating puzzle, right? The constantly shifting, seemingly random ports that Active Directory uses for replication. Well, today we are going to crack that puzzle wide open.
So, let's start with the central question. Just imagine for a second you have to deliver a really critical message to a building, but the door number changes every single day. How in the world do you find it? Believe it or not, this is the exact challenge Active Directory faces every time it needs to replicate data.
And this really gets us to the heart of the replication puzzle. See, Active Directory replication is literally the lifeblood of your network. It has to work. But by default, it uses these dynamic, constantly changing ports. Now, it's a design choice that gives it some flexibility, but for us, it can feel like you're trying to hit a moving target. Okay, so the technical term for this whole thing is dynamic port mapping. What's happening is the server essentially just grabs a temporary, high-numbered port for the conversation. Think of it like a secret door that only exists for one single session. So the question is still there. How does the client ever find out which door to knock on? Well, just like our building with its random door numbers, there has to be one place you can always go for information, right? A universal front door. A main reception desk that never, ever moves. And here it is, the hero of our story, the RPC endpoint mapper. RPC stands for Remote Procedure Call. It's just how these services talk to each other. And the endpoint mapper? It basically acts as the server's own internal directory assistance. Its one and only job is to keep track of all those secret doors and tell clients exactly where they need to go. And that universal front door, that one place you can always go, it's TCP port 135. The RPC endpoint mapper is always listening right here. This is the first absolutely crucial piece of our puzzle. Okay, so now that we know where the whole conversation starts, let's take a look at the secret handshake itself. It's this really elegant four-step dance that lets a client connect to the right replication port without ever having to know it in advance. It's actually a beautifully simple process when you break it down. Step 1. The client knocks on that universal front door, port 135. Step 2. It asks the endpoint mapper, hey, can I get the directions to the AD replication service? Step 3. The mapper says, sure, here's the secret temporary port number. And finally, step 4, the client says thanks, hangs up, and immediately calls back on that new port to start doing the real work. The client never had to guess. It's brilliant. Now the endpoint mapper, that's our star player. It's the one who knows the secret. But replication is a team sport. It can't do its job all by itself. It actually relies on a whole crew of other essential services to get the job done right. So yeah, while the replication itself happens on some random dynamic port that we find using 135, that whole process is supported by other critical services that live at static, well-known ports. You can think of these as the permanent office numbers that just never change. And here they are. For anybody out there managing firewalls, these ports are completely non-negotiable. You absolutely need DNS, the domain name system, just to find the server in the first place. You need Kerberos for secure authentication, and of course, LDAP, the Lightweight Directory Access Protocol, for querying the directory itself. These ports have to be open for business, period. Let's break down their roles with a little analogy to make it stick. DNS on port 53, that's your map. It tells you how to get to the building. Kerberos on port 88 is the security guard. It's going to check your ID to make sure you're allowed in. LDAP on port 389 is the address book you use to find people inside. And what's really interesting is that another service, the File Replication Service, or FRS, it acts like a courier, and it uses this exact same dynamic RPC process to do its job. So why did we just spend all this time uncovering this secret handshake? Well, because understanding this process is absolutely fundamental to network security, to administration, and especially to troubleshooting. And here is where this knowledge becomes so critical in the real world. A super common mistake is for someone to open port 135 on a firewall, but then block all those high-numbered dynamic ports. And when that happens, yeah, the client can ask for directions, but it can never actually reach the final destination. The secret handshake fails at the very last step. The solution, of course, is to allow the initial question on 135 and the follow-up connection on that dynamic port range. So we'll leave you with this one thought. Now that you understand the complete conversation, from that initial knock on port 135 to the final chat on some random dynamic port, take a look at your own network. you now know how Active Directory talks. The real question is, are your firewalls actually configured to listen?